Hi dear students. So the next topic that we are going to discuss here is the nomenclature of amines. Okay. So coming to the amines, you know its representation can be, amines can be of different types actually. We say if NH2 is there, we say it is primary amine. Sometimes one of the H will be replaced by some other group, some other substituent. Then NH will come. In that case, we used to say it's a 2-degree amine. And sometimes all the 3H will be replaced. In that case, we say 3-degree amine. Usually, amine, the group is derived from ammonia, NH3. From that, when one H is replaced, you will get the primary amine. And NH, 2H is replaced, then we say 2-degree amine. And 3H, all the 3H is replaced. In that case, we used to say it's a 3-degree amine. Okay, now the suffix. As you know, whenever there is amine group is present in a compound and it behaves like a functional group. Okay, in that case, the suffix used is amine, A-M-I-N-E, amine itself. Now, there can be cases where carboxylic acid is also present along with amine. In that case, we know that carboxylic acid will behave like the what? Functional group. It should not be carboxylic acid, it can be aldehyde, ketone, who and all, if you see, they are all above amine only. So when those groups are present in the functional groups, then that particular group will behave like the functional group and its suffix is used. Now in that case, amine will behave like what? A substituent. So in that case, the prefix is what we will be using. So the prefix for amine group is amino. Okay, what it is? Amino. Understood? Now we will try to see some examples of how to do the naming for amines. Okay. Please listen, this is very important for exam point of view. Now, the first question here is, you could see NH2 group is connected here. So, it's a primary amine, I could understand. Now, the methodology says that this is a non-carbon functional group. Non-carbon means the amine group itself does not have any carbon. Then, as per the naming convention, what the rule says, the amine group will be connected to some particular carbon atom. That carbon atom should be part of the parent chain. This is what rule says. Correct. So I know that this NH2 group is connected to this carbon. So this carbon should be part of the longest chain. So I know that this is my longest possible chain. Correct. So I have chosen that. Next step is numbering. So while numbering, I should ensure that this amino group should get the minimum possible number. So if I go from left to right, you will get 2. If I go from right to left, then also the number 2 will come. So I can choose any one of that. 1, 2, 3. So the numbering is also completed. The next step is putting the name. We know that there is no 2-degree prefix is applicable as there is no substituent present. 1-degree prefix is also not applicable because it is not a cyclocompound. Correct? Now, first we will then start with after 1-degree prefix what is present, we know the word root. So word root means 3 carbon atoms are there, means it will be prop. Correct? All are linked through single bond, that means AN. Correct? Now we know that then what will come? So AN comes means 1-degree suffix also came. Now the 2-degree suffix at what position? Second position. So I can say propan 2-degree suffix is what here for amine? It is amine, amine. So I will add amine here. Understood? So the prop is the word root, an it is the 1-degree suffix, and 2-amine is the what? 2-degree suffix. Correct? So this is the way we need to name it. Now comes the next category where you have a 2-degree amine is present. So here from here only the confusion starts for students. So they will ask here, sir, here NH is present, but which one I should consider as the parent chain? Here one CH3 is there, here CH2, CH3 is there. So which should be the parent chain? There is no much difference between these and two. Please understand, whenever 2-degree amines come, the first thing you need to choose is you should look at both parts and identify the longest possible chain. Now if I am looking at here, I know that there is only one CH3 is there. If I am looking at here, I know that CH2, CH3 is there. So the longest part is CH2, CH3. So that will be my longest chain. So this will be my longest chain. CH2, CH3 will be my longest chain. Now, then what will be this CH3? We can assume like one H is replaced by CH3. So whenever you are naming a secondary amine, the methodology is when one H is replaced, we will say N-alkyl. Okay, N-alkyl. So here N, instead of alkyl, who is coming? Methyl group is coming. So we can start with, please remember always that should be started with N-alkyl. So here it is N-methyl. Okay, N-methyl. Then the remaining thing like this. Now who will come thereafter? So the common suffix name is alkyl alkanamine. So N-alkyl I have given. Next 2 degree prefix I will check for. Any 2 degree prefix is there? Substituent stands for 2 degree prefix. So we know that in CH2, CH3 no substituent is present. And then I will check for 1 degree prefix. 1 degree prefix means cyclo, that is also not present. Then comes what? The word root. So I should do the numbering. So this is 1 and this is 2. So the word root means how many carbon atoms are there? 2 carbon atoms. So I know for 2 carbon atoms it is eth. These are connected through single bond. So we say ethane. Correct? And at first position you have the amine present. So 1 amine. Understood? So N-methyl ethane 1 amine. This should be the way you need to name the 2 degree amines. Understood? Now coming to another example of a 2 degree amine, because 2 degree amines always create confusion for students. That's the reason why I have given one more. Again I am looking into NH. Here one part is there, here one part is there. So here only one carbon atom. Here 1, 2, 3 carbon atoms are possible. So which one is the longest chain? This part. So I can say, okay, while this is my continuous longest parent carbon chain. Now we know that if I go from left to right or right to left, the number 2 will come to the carbon atom which is connected to NH. So 1, 2, 3. So how will you name this compound? Again here CH3 is coming to the here. So I can say N-methyl, correct? N-methyl. Then how many are there in the parent carbon atom? 3 are there. So prop, they are connected through single bond. Then propan, correct? At the second position you have the amine group connected. So I can say propan 2 amine. Understood? So N-methyl propan 2 amine. Now comes the last one. So here if you see in the last one, you could see here it's a 3 degree amine because there is only N is present and 2 H is replaced by CH3 and other by a cyclo compound. In this case we need to compare all the 3. Here in this case only 1 carbon atom is present. Here also 1 carbon atom present, but here if you see 1, 2, 3, 4, 5 carbon atoms are present. So who should be the parent here? The ring should be the parent. Correct? Now in this case then how I can write? I can say NN because 2 times H is replaced. So I can say N, N dimethyl. Correct? N, N dimethyl. Sometimes this can be C2H5. Then in that case we can say N-ethyl, N-methyl. Both are different. Understood? Here both are same. So we say N, N dimethyl. Then while numbering we know this should be getting minimum number 1, 2, 3, 4, 5. So I can say 1 degree here 2 degree prefix is not there. There is no substituent in the parent ring. But 1 degree prefix is there because it is a cyclo compound. So we will say cyclo. Then word root 5 carbon atoms. So we say cyclopent. Correct? Then they are linked through single bond. Okay, I am rubbing this. Okay, they are linked through single bond. Then I say pentan. At first position you have the amino group connected. So pentan 1 amine. So the answer is N, N dimethyl cyclopentan 1 amine. Understood? So this is the way you need to name amines. We will see more examples. Okay. So hi dear students. So let's see some examples for the nomenclature of amines. Okay. So in the first case itself I have given you a special compound. This compound, okay, this is the first one. This compound, its common name is widely accepted as IUPAC name. So that you don't want to give any new name like benzene amine or nothing like that. Benzenamine, some students used to say. But more correct answer is this, the common name here is aniline. So anything derivative of this we say in terms of aniline only, because this is a widely accepted norm. There are certain common names which is widely accepted as IUPAC name. So one among that is this one. Okay. So I will give you that list. Those things you should remember that name only. Common name only. You should remember it as IUPAC name. So here this is aniline. So how will you say then this one? I know that N-methyl. What is the common compound? Aniline. So I can say this is N-methyl aniline. Okay. N-methyl aniline. Now coming to this one, third one. Now if you see here, you could see here methyl group is connected, here methyl group, and here a longest chain is connected. Okay. So I should find there is no substituent or there is no double bond or functional other things connected. So we can directly identify the longest possible chain. So here I know if I try to select the longest possible chain, that should be this one. Correct? And I have tried to include the amino group which is connected to some carbon atom. That carbon atom is also part of my parent carbon chain. Now if I am numbering, I should give this the lowest possible number. So 1, 2, 3, 4, 5. Correct? Now next thing is putting the name for the compound. So I know that it is a tertiary amine. So N, N both are methyl. So we say N, N dimethyl will come. But wait, at the second position the substituent is also methyl. So I can say N, N 2, 2. Why 2, 2? Because 2 CH3 group at the position 2. 2, 2. How many CH3 are there? 1, 2, 3, 4. Then we say tetramethyl. Very, very important. So I can say the name as, listen, N, okay, N, then 2, 2 hyphen tetramethyl. Okay, N, 2, 2 hyphen tetramethyl. So 5 carbon atoms in the word root. So I can say pent. All are connected through single bond. So pentan. At the first position you have the amine. Pentan 1 amine. Okay, N, 2, 2 tetramethyl pentan 1 amine is the correct answer. Now coming to the next question. So here also you can see amino group is connected to a cyclohexane ring. So here this amino group does not include any carbon, but this is connected to one carbon atom. So that is part of the parent chain. So I can start numbering from here 1, 2, 3, 4, 5, 6. So what should be the name? Since it is a cyclo compound, I know the 1 degree prefix will come. So I will say cyclo. 6 carbon atoms are there, so I use the term hex. All are connected through single bond, so we use a hexane. At the first position you have the amine, hexane 1 amine. So some books say it is cyclohexanamine. That is also correct since position 1 is there. It is not mandatory that always position 1 needs to be mentioned. Okay. So cyclohexane 1 amine is the correct answer. Now coming to the last one. You have CH3, 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 all are equal. So in this case you can take any one of the CH3 as the parent carbon chain. So let me take this as my parent carbon chain. So there is only one, that's it. So how I can say NN dimethyl. Why? It's a tertiary stuff. So here many students will ask, sir, three methyl groups are there, right? So why don't you say N, N, N trimethyl? Then where is the word root? That is the problem. Then we need to choose one as the word root and we need to say the other as the substituent. So we say N, N hyphen dimethyl. This is completed. One carbon atom. So we use the term meth. That is connected through single bond, so methane 1 amine. Okay, so N, N dimethyl methane 1 amine. So this is not clear, I hope. Methane 1 amine. So I hope you understood all the examples. If you have any doubt, please come back to us. Okay. Thank you. So next we are going to see a similar thing, but there are two amine groups connected. So what we will say diamine, correct? So earlier we have seen dinitrile, dioic acid. In all those cases, what is the only thing to be remembered? When 1 degree suffix is present there, whether ain, that E should not be removed. Very, very important. Okay. Now let's see here. So here I could see NH2 connected here, NH2 connected here. So this is a carbon atom, this is a carbon atom. So my parent carbon chain is this one, correct? Since it is a symmetrical compound, I can give one here or I can give one here. Both are correct. Okay. Now we will see there is no 2 degree prefix is there, no 1 degree prefix. Coming to the word root, 2 carbon atoms. So eth. They are connected through single bond, so ethane. So here I am not removing the E. Please remember. Why? Because 2 amino groups are there. Whenever 2 similar substituents are there, don't remove the E there. Okay. So ethane hyphen 1 and 2 position. 1, 2. How many are there? Di. Because 2 are there. So diamine. Ethane 1, 2 diamine. Okay. Now coming to the next one, here you can see one primary amine is connected and other is a secondary amine is connected, correct? So we know that again we need to number it. So numbering can be 1, 2, 3 or it can be 1, 2, 3. Either way you can number it. Okay. So either ways we can number it here. So some students will feel, sir, here do we need to give priority to secondary amine or 1 degree amine? There is no difference. Why? Because whether it is secondary amine or 1 degree amine, we are using the suffix amine only. So you can give priority to anyone, whether this one or this one. So let me say this is my parent carbon chain. Correct? Now I am giving the number 1, 2, 3. Correct? Now how should I start? Since there is a 2 degree amine is there, I know that N methyl is there. This free end denotes methyl. So I can say N hyphen methyl. Then comes the word root, 3 are there. So prop. They are connected through single bond. So propane. Correct? Now at position 1 and at position 3 you have 2 amino groups. So I can say propane hyphen 1, 3 hyphen diamine. Understood? So you can even number from here also 1, 2, 3. Then also no difference. 1, 3 only will come. 1, 3 again diamine. Okay. So I hope you understood this question. Now comes this one. This one is a very good question. Now if you see here, you have a tertiary amine and a secondary amine coming as a combination. So here also my longest possible chain is this one, correct? So I can give priority to anything. Anything is correct. I give 1 here, 2 here. Both are amines, so I can give it like anyway. So now listen here. I know that N, N 2 methyl groups. So N, N dimethyl will come. Here N methyl will come. So here whenever 2 degree and 3 degree amines are coming, we need to differentiate between the N. Because I cannot say all are N. So one is, if I am representing here as NN dimethyl, this should be N dash. Understood? So I can say it like this. N, N, N dash. Understood? This N dash represents, it is another amine actually. N, N dash hyphen, how many methyl group are there? 1, 2, 3. So I can say trimethyl trimethyl. Again the same thing. How many word root? Tell me 2. So I say eth. They are connected through single bond. So we say ethane. Correct. At position 1 and 2, 2 amino groups. So ethane 1, 2 diamine. Understood? So N, N dash, trimethyl ethane 1, 2 diamine. Some students will say, sir, whether I need to put N dash first or N first. Both are correct. You can keep either N dash first or N first. There is no much difference. So N, N dash trimethyl ethane 1, 2 diamine is the correct answer. Understood? Now suppose this is ethyl, means what you need to do? N, N dimethyl hyphen N dash ethyl, then only it will come. Understood? Now let's see the other question. It's a good question where you have COOH group present along with NH2 group. So we know that when two functional groups are present in an organic compound, we should consider the priority. So NH2 amino group, other is the oic acid, carboxylic acid. Who will get the priority in the priority table? Carboxylic acid. So here NH2 should behave like what? It should behave like a substituent. So in this case, I can say this is my parent carbon chain. So while numbering, this is 1, this is 2 and this is 3. Correct? So whenever NH2 behave like a substituent, what is the term we use? We know that if it is a substituent, we use the term prefix, and the prefix is amino. So since this is a substituent, the 2 degree prefix will be what? 3-amino. Correct? Then comes the word root. Word root is prop. Correct? They are connected through single bond. So propan. At the first position, oic acid, propan 1 oic acid. So 3-amino propan 1 oic acid will be the IUPAC name of that compound. So I hope you got a fair idea regarding how to name the amines. Now we will go to ethers. Okay. So last come, the topic is ethers. Actually we should not learn separately the nomenclature of ethers, because ethers is not a functional group separate. Because since we have a chapter alcohols, ethers, so we are considering ethers as a separate topic. So the first point to remember here is ether is not considered as a functional group. Ether is basically a substituent, very important. So if ethers are substituent, how it is represented? The common representation is hyphen or valency OR. This R is an alkyl group. Okay, so we use the prefix alkoxy. Why prefix is only there? Because it is a substituent. So alk means this alkyl part, oxygen, oxy, alkoxy. Okay. Now for example, you have OCH3 is coming. Then what we will say? Methoxy, methoxy. And if you have OC2H5, we know that this is ethyl with oxygen. So we say ethoxy, ethoxy. Understood? So we will try to name some compound, then you will understand a fair idea. Okay. Please listen here, CH3OCH3. Now you will have a doubt here, both are symmetrical. OCH3 can be taken like this or OCH3 can be taken like this. So please remember, you need to take the smallest one. So both are symmetrical means I will take any one of them as my parent carbon. So this is my parent carbon chain and this is the substituent OCH3. Then how I will name it? Please tell me. The first comes the substituent because it is the 2 degree prefix. So substituent here is what? Methoxy, correct? Methoxy. Then comes the word root. Word root is meth, correct? 1 carbon atom. There is linked by single bond. So we say methoxy methane. Understood, I hope. Now comes the next one. Here comes another doubt. Sir, here OCH3 is there. Either I can take OCH3 or OCH2CH3. I have a doubt. Then what you need to do? Longest one should be considered as the parent. So this is the longest one. There is no double bond or other groups. So we can say the longest chain is the parent. Correct? Then what? This is OCH3. Then I can say again my 2 degree prefix is methoxy. Correct? So methoxy. What is this one? If I number it, this is 1, 2. So 2 carbon atoms means eth. They are connected through single bond means ane. Correct? So I can say methoxyethane. Understood? Now coming to this one, third one, please listen. So here OCH3, here only one CH3, here it's the biggest chain. So So this is my parent carbon chain. Okay, this is my parent carbon chain. Now I should number in such a way that this substituent should get the lowest possible number. We know that the priority goes to functional group, then comes the multiple bonds, then substituent. So here substituent is present, that is, so that should get the lowest possible number. So 1, 2, 3. So if I do it in the other way also, the 2 will come. So at the second position you have the substituent OCH3, then what we will say, 2-methoxy, word root has 3 carbon atoms, so we say prop, and they are linked through single bond ane. So my answer is 2-methoxypropane. Okay, so I hope you got a fair idea regarding the nomenclature of others. So the next in the list what we need to learn here is okay, one more thing I need to say. What about this compound? Suppose benzene is coming along with this one, okay, OCH3. This is a famous compound. So here also what you can say, methoxybenzene. Okay, so you can say either methoxybenzene, or it has a common name, very popular, methoxybenzene, or we will say this compound as anisole. Please remember. So this compound we called as anisole, or the other IUPAC way of saying is methoxybenzene. Sometimes this anisole is also accepted as the IUPAC name. Okay. Yeah. So I hope you understood this topic. Now we will go to the next concept, that is called naming of complex substituents. Okay. Okay. So what we are going to learn next is the nomenclature of complex substituents. So in the case of complex substituents, first we should say, whenever a question is given, how will you identify whether there is a complex substituent or not? This we can identify after identifying the longest possible chain. Now if you look into this compound, we know that there is no functional group present, there is no multiple bond or anything. So first the methodology says that what is the rule of naming? We should identify the longest continuous parent carbon chain. So let's try to identify that. See here, 1, 2, 3, 4, 5, 6, 7, 8, 9. If I go in straight way, you have 9 carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9. If I go in this way also, you have 9 carbon atoms. So let's go the other way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means this is the longest possible chain. So let me choose this as my parent carbon chain. Okay, longest continuous parent carbon chain. Correct? So we have chosen this. Now comes the question, what are the substituents here? Here is a methyl group, here is a methyl group, and this, how you can say this, what is a substituent here? I can say this type of substituent is called a complex substituent. So this is this I can say it is a complex. I am giving a cloud like symbol. Don't think it is a parent carbon chain. So this is this something that is put it in black. It is the complex substituent. We cannot say methyl, ethyl or anything. In this case, we will do a special mechanism. I will explain that. So here the first case here is you have methyl group, no issues. Now we need to number it. We know that if I do the numbering from here, 1, 2, 3, 4, 5. The first locand that is coming here is 5, correct? 5, comma, then 6, 7, 8, 9. So 8 and 9. This is the locand position. Now if I do it from here, 1, 2, 3. So 2 and 3 will come. 2, 3. 4, 5, 6. Then 6 will come, correct? So from the first one itself we could understand that this is the smallest number. So this numbering is correct. Correct? So I will give numbers like that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Understood? Now listen here. When it comes to the complex substituent, you need to do a separate numbering for their naming. That means first identify the carbon atom that is connected to the parent chain. I understood this is the carbon atom that is connected to the parent chain. Then choose that carbon atom as the number 1 carbon atom. Okay, number 1. Then what you need to do is the same method, you need to identify the longest possible chain that is present in the substituent. So I know that 1, 2, 3, then also 3, 1, 2, 3, then also 3. So both are correct. So I will give 1, 2, 3. So you need to number it like this. Okay. Now I will help you how to now give the IUPAC name. So up to this much you need to do. Okay. So while giving the IUPAC name, first thing is what actually 2 degree prefix will come. Correct. So 2 degree prefix stands for the substituents. So here what are the substituents present at 2 and comma 3, 2 and 3, what is the position? You have dimethyl is present, correct? This is one substituent, first one. And you have another complex substituent at position 6. So I can say 6, this is for your understanding, I am writing like this, then I will write it in one single format. 6 hyphen. Okay, whenever complex thing is there, okay, here also hyphen is there, hyphen, then put a bracket, very very important, to indicate that it is a complex substituent. Put a parenthesis. Okay, now inside the parenthesis, first mention the name. So we know that here at the second position you have the substituent, correct? Please remember, this is now, it's almost like a new naming. Inside the parenthesis, you are going to name the substituent. So in here we know that who comes the substituent or the 2 degree prefix. In this case, it is the methyl group at position 2. So I can write 2 methyl. Okay, put a hyphen here. So 2 methyl. Now word root, how many carbon atoms are there here in this parent? 3 carbon atoms. So we say prop. Okay, so we say prop, P-R-O-P, prop. And I know that since it is a substituent, I should add what? Propyl. Then close the bracket. That's it. Understood? So 6 hyphen 2 methyl propyl. So there are 2 substituents here. One is in the parent chain 2, 3 dimethyl and 6 hyphen 2 hyphen methyl propyl. Now alphabetically who will come first? We know that di, tri, tetra, all those things are not considered for alphabetical comparison. So here methyl, M is starting, here also M. Then if you see here up to here it is same. Then comes here propyl also. So alphabetically we say this will come first, then only this will come. So I can say, how I can say, tell me, 2, 3 hyphen dimethyl. Okay, put the hyphen, 6 hyphen bracket 2 methyl propyl, 2 methyl propyl, close the bracket. Two methyl propyl. Then this hyphen is there, so please close that hyphen. 2 methyl propyl. Okay. So 2 methyl propyl. Now tell me parent carbon has 10 carbon atoms. So my word root is dec and they are connected through single bond. So ane, decane. So my name is 2, 3 dimethyl 6 hyphen 2 methyl propyl decane. This is the way you need to name the compound. Okay. Now let's try another example here. So you have another question here. So again, if you are looking into this question, there is no functional group is present, there is no multiple bond, it is just hydrocarbon, right? So first step is what? Identifying the longest possible chain. Please look here. So if I am trying to choose 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 carbon atoms I can identify. Suppose if I am going like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then also 10. If I go like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then also 10. So we know that whenever you have chains that are of same length, then what is the rule says? Please go to the rule. The rule says that try to choose the path which has the maximum number of substituents. So that means if I am going to choose this linear chain as my path, then I have substituent here, this is one substituent, and I have a substituent here. So there are only two substituents present. Now if I am going to choose this as my path, okay, something like this. If this is my path, now see here, you can see one substituent here, you can see it is present outside the ring, one substituent, another substituent, and you have a bigger substituent here, this one. Correct? This is a bigger substituent or my complex substituent. So there are 1, 2, 3 substituents are there. So that means maximum number of substituents are present when I choose this as my parent carbon chain. So this is my parent carbon chain in this case. Okay. Now I need to number it. Now if I am numbering from here 1, 2, 3, 4, 5, 6, 7, 8. Then I can say 6, 8, 8. 6, 8, 8 is my locant. Now if I do it in the other way, 1, 2, 3, then I know that 3, 3, then 4, 5. 3, 3, 5 is the. So on comparing the first element itself, I understood this is the lowest number. So this is my numbering method. So I can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Understood? So I hope you got understood up to this much. Now again I am looking at the 2 degree prefix. There are 2 methyl groups. So I can say 3, 3 dimethyl is present. That is one of my 2 degree prefix. And other one is a complex one. So let me say in cloud. Okay. So this is my complex substituent. Now as I told, whenever you are naming the complex substituent, what is the first thing you should do? The carbon atom which is connected to the parent chain, that should be marked as number 1. Very important. So once this is marked as number 1, try to identify the longest possible chain. I can go in this way 1, 2, 3, 4 or 1, 2, 3, 4. Both way if I do, you will get the same name. So let me choose this way 1, 2, 3, 4. Okay. Now I know that my 2 degree prefix, I will just list it here. I will write down here for your understanding. 2 degree prefix. What are the 2 degree prefix available? So we know that at 3, 3 you have dimethyl. Correct? 3, 3 dimethyl is present. Then at the fifth position, so hyphen, then put open a bracket. Why? Because it is a complex substituent. So at the fifth position you have, again at the second position here inside this one there is an ethyl group. So I can say 2 ethyl. Again once you open the bracket, it is again like a new numbering. Understood? Again like a new naming. So in this first who will come 2 degree prefix. So at the second position you have ethyl. So 2 ethyl. Now the parent chain has how many carbon atoms? 4. So but, and I know it's a substituent, so butyl. Then close the bracket. So these are the 2 substituents present. Now I can name it. So now compare it. Who will come alphabetically first? This is M, correct? This is E. We know that di, tri, tetra and all we will not consider actually. So M here E. So E will come first. So I can first write it as 5 hyphen 2 ethyl butyl, correct? Close the bracket. Then comes another substituent which is a number, so that's the reason why I keep a hyphen here. Then I will write 3, 3 hyphen dimethyl, correct? So 2 degree prefix is completely over. Now 1 degree prefix is not applicable. Then comes the word root, 10 carbon atoms. So we say dec, and they are linked through single bond, ane. And 2 degree suffix is not there since there is no functional group. So I hope you understood. 5 hyphen 2 ethyl butyl 3, 3 dimethyl decane. Okay. So we will try to do the next question. Okay. So here also first thing to identify here is whether there is any functional group is present or not. Okay. Is there any functional group here? I can see here there is no functional groups present, there is no multiple bonds present. Then my methodology is identifying the longest possible carbon chain. So let me say 1, 2, 3, 4, 5, 6, 7, 8 is there. 1, 2, 3, 4, 5, 6, 7, 8 is already there. 1, 2, 3, 4, 5, 6, 7, 8, 9 is there. So I can say this is my parent carbon chain. Identify the longest possible carbon chain. So this is my parent carbon chain. So I can number it now 1, 2, 3, 4, 5. So if I go from left to right, 5 is the number coming here for the substituent. 1, 2, 3, 4, 5. Here also 5 is the number. So I can go in any way. Okay, let me go from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. If you go from left to right also, it is correct because it comes at the symmetrical position 5. Now I know that this is my complex substituent, correct? So this is a complex substituent, I could understand that. Now next thing is numbering the complex substituent. So the carbon atom which is connected to the parent chain should be numbered as 1. Now I need to choose the longest possible path. 1, 2, 3 or 1, 2, 3, 1, 2, 3. Both are correct. Because if I go by this way also 2CH3 group, if I go by this way also 2CH3. Anything you can choose. So 1, 2, 3. I chosen like this. Now how to name this compound? Tell me. 2 degree prefix. There is a complex substituent. So how will you name that complex substituent? You know that 2, correct? 2. So since initially itself it is coming, at what position it is coming? 5th position. So I will say 5 hyphen bracket open, correct? 2 comma 2, correct? Hyphen dimethyl, correct? So this is the complex substituent. So dimethyl. Then any other substituents are there? No. So 5 hyphen 2 comma 2 dimethyl. How many word root? 9 are there. So none. So here you don't want to put the hyphen because there is no numbers. None, because 9 carbon atoms. All are linked through single bond means 8. So my answer is 5 hyphen 2 comma 2 dimethyl nonane. Understood? So this is the way you need to name a complex compounds. There are more rules are there. I will tell one special case where if you have a similar functional group, similar complex substituent here also at the 5th position, one more H is replaced and the similar stuff is here. In that case, whenever you have 2 similar substituents are present, 2 similar complex substituents are present. Now we know that if it is 2 methyl group, we use the term di. So similarly, if there are 2 similar complex substituents are present, 2 means we use the term bis. We use the term bis. Suppose there are 3 similar complex substituents are present. If it is 2, then we use the term tris. If it is similar 3 complex substituents are present. Okay, we will see those examples in the next class. Okay. This is not present in the NCERT text, but this is very important for JEE and other stuffs. So Neet students, you can learn it, it's okay, but I don't think so this will come for the exam since it is not present in NCERT. But you need to understand this. This will come for our model exams and other things, because when you learn something, you learn completely, so that any course you can go with 100% confidence. But if you are not learning, you will be always having that fear whether that question will come for the exam. Then surely that will affect the confidence of the other questions also. Okay, so please understand this. If you have any doubt, get back to us in doubt clearance session. Okay.